Hello, hello. Alright, kids. Import, import file. Sorry, wait, wait. Import or export? Import, 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 import file. Learning skill, learning page, download. 1 second, kids. I'm not able to find. Okay, anyway, what I'll do is I'll re-download it. I'll not download the file again. I'm not able to figure out where the old file is. Just hold up, kids. I'll download it again. Okay, there it is. Okay, so last time we did some problems, if you remember. We did this question also. You know, we did a bit of problems. Now what we'll do is we'll move ahead. We'll go ahead and do some theoretical part also, other than the problems. So there are a lot of other problems that we could do, but then we don't have the time to do all the problems. So these problems you can do it as a homework, right? And then let me know which questions you're not getting. So then we'll do those questions. As of now, we'll go ahead uh, with the theory, right? So let's see. So let us see what is electric field intensity. There's something called electric field intensity. Now, what is it? Let's see. Electric field intensity. Books call it electric field. Books call it electric field. So kids, electric field is not a correct word. Correct word is electric field intensity, even though books call it electric field. I will also call it electric field. Why? Because it is shortcut way of saying electric field. No? Instead of saying electric field intensity, in short, I will say electric field. But books call it books also call it electric field, but actually it is what? Electric field intensity is the right word, as in first time I'm telling you, I have to tell you what is the correct word. It's electric field intensity. What is electric field intensity? It is a vector quantity, right? It's a vector quantity, which is defined as ratio of force at a particular point and value of the test charge at that point. So what does it mean? Let us say, no, listen to me very carefully. Forget about everything that's written here. I'm going to tell you what electric field is, how do you calculate it, and listen to the procedure. I'm going to tell you. Then I will get into what is written here. That is the second part of it. I'll come to that. Let us say that there is a charge here. Call it source charge. Charge here. I'm calling it source charge. Because of that, at point P, let's say at any point P, I want to find out what is the electric field, right? So that is what I want to do. What am I doing again? Let me tell you again what we are trying to do here is there is a source charge, because of this I want to find out what is the electric field at point P. Intention is clear. How to do that, how to find out electric field at point P, I'll tell you now. Now listen to what I'm going to do. To do that, the first step is to get a charge here. Okay, got a charge Q, call it QT. Okay, what is QT, bachcho? What is QT? QT is called the test charge. First of all, QT means test charge. It is a point charge. It's a very very small point, and it is generally taken to be positive, right? So QT is positive. Okay. Again, I wanted electric field at point P. For that, I brought a charge there, QT, and because of QT, I'm trying to find out the electric field. Right? So what is the electric field? Let's read. It is the ratio. Ratio of what? Force at that particular point divided by value of the test charge at that point, means force divided by QT. That ratio gives you the electric field. Agreed? F vector by QT gives you the electric field. Okay. And what will be the unit? Force by QT, means force is Newton, QT is Coulomb. So Newton upon Coulomb is the unit. Okay. What is the reason we take QT tending to 0? Why do we take QT tending to 0? What is the reason? QT tending to 0? We take QT tending to 0. Okay. See, why we brought QT here at the first place? To measure electric field, right? Electric field is F divided by QT. What is F here? F is the force on QT. By whom? By the SC. SC means source charge, right? So electric field is force on QT divided by force on QT by the source charge divided by QT. That is electric field. And QT is called the test charge. It's a point charge and it is generally taken as positive. Now, why do we take QT tending to 0? What is the reason we take small test charge? Is because if the test charge is very large and powerful, it will change the source charge. If the test charge is very strong, it will change the source charge. And if it will change the source charge, will I be able to measure the correct electric field, or I'll be measuring wrong electric field? I'll end up measuring wrong electric field. Because why wrong electric field? Because I wanted to measure the electric field of the original source charge. But unfortunately, due to the presence of Qt, which is so strong, if it is strong, it will destroy the very original source charge whose electric field I wanted to measure at the first place. Got it? Right? That is why Qt itself should be tending to 0, because it is only here, Qt is only here so that I could calculate the electric field of the original charge. I don't want to disturb the original charge. I want a small charge, that's why, right? And electric field is what? As I said, force on Qt by the source charge divided by Qt. That ratio will give you the electric field. That is force by charge means Newton by Coulomb. That is your unit. Okay. Whatever I told you, those steps are written here. So what are the steps? To find electric field intensity at a point, first bring a test charge to that point. So you want to find electric field at this point, first bring the test charge there. Find the force on the test charge, find the force. Divide that force by the value of the test charge, divided by the value of the test charge, right? Generally the charge is taken as positive. What do you get? Whatever you get is called EFI. EFI means electric field intensity, represented by the letter E. Bar, because it is of course it is a vector quantity, right? So take this down. Right? Electric field due to a positive charge. So if a charge is positive, electric field due to it will be away, away, right? Due to positive charge. So direction will be away. And magnitude will be how much? Let's find that out. At this point, I want to find electric field. And electric field is formula is k q by, let's say q is this charge, k q by r square. And electric field will be away. Away means this way. The formula is k q by r square. And here itself I'll draw, if it is a negative charge, for negative charge electric field is towards, you know, and at a distance r it's towards, and E is given by kq by r square. But here it is towards, there it is outwards, here it is towards electric field direction. Make it. Let's go ahead. This done, negative positive charge, both we have done. How to find force on a at a point on a positive charge when electric field intensity is given? So let us say electric field intensity is given. At this point electric field is in this direction. You know? Let us say at the same point you have a positive charge is kept there. Right? So this positive charge Q will experience force in which direction? Along electric field or opposite electric field? It will be, for positive charge it will be along. Force will be along. And that F is given as 2 into E. And let us say that at this point electric field is in this direction, but at this point we have a negative charge, let's say minus Q. So where will be the force on this charge? Electric field is in this direction. Force will be in which direction? It's a negative charge. Force will be in the positive direction. For negative charges, it's in the opposite direction, right? But the value of F is again 2 into E, correct? So behavior is different. So here, here means for positive charge. Force is parallel to electric field. And for negative charge, force is anti-parallel to electric field. Anti-parallel means opposite direction, right? Okay, let's go now. Principle of superposition of electric field. The resultant electric field is the vector sum of the electric field due to individual charges. So on one charge, net electric field will be the sum of the electric field due to other charges. So let us say this is the electric field due to some other charge, this is the electric field due to some other charge, right? So at one point, net electric field will be the sum of the two electric field, right? Net will be equal to E1 plus E2, and so on. If there are more fields also, then also so on. That is principle of superposition. I think this is very straightforward. Net electric field is the sum of the electric field. There is nothing I have to tell you there. Now see, 2 point charges are separated by a distance L. One has charge 2q and another has charge minus q. Right? I am calling this 2q, I am calling that minus q. Why? Because I am taking let q equal to 25 microcoulomb. That is the charge. You know, 55 microcoulomb. So 2q makes it 50 microcoulomb and minus q makes it minus 25 microcoulomb. Determine the direction and magnitude of the electric field at point P between the two charges, that is 2 centimeter from the negative charge. So they are saying that there are two charges, 2q and minus q. Distance between them is how much? L. Right? Determine the direction and magnitude of the electric field at point P between the two charges, that is 2 centimeter from the negative charge. So what they are saying is there is this charge to q, and there is this charge minus q. Plus 2q and minus q, and the distance between them is, let's say, r, and distance between them is 10 centimeters. It's L actually. L is 10 centimeters. Then what do you have to find out? You have to find out the electric field at which point? T. Between the two charges, that is 2 centimeters from the negative charge. So here, at this point, right, which is 2 centimeters. Or let's call this 2 centimeter B. Right? B. Right? At point P, at a distance B, we have to find out. So let us find out the electric field at point P, right? 2 centimeters from the negative charge. And what is B, guys? B is 2 centimeters. This B is 2 centimeters from the negative charge. Yeah? I want to find the electric field. How do I find out? I just studied that net electric field is the sum of all the electric fields. So let us find the electric field due to one charge. Then let's find the electric field due to the other charge and add the two electric fields. Right? No, that is straightforward, right? That's what I'm going to do. Let's do it. So let's find the electric field due to the positive charge first. Because the positive charge electric field here will be in this direction. Call it E1, and the formula is K into 2Q, okay, divided by distance square. How much is the distance? L minus B. A whole square. Now, due to this charge minus Q, electric field will be in which direction at point P? Tell me. Towards or away? It's a negative charge. So it will be towards. Call it E2. Because I told you, because of negative charge electric field is towards, right? See? Here. Due to negative charge electric field is towards. But because of positive charge, electric field is away. That's why due to positive charge I've drawn it away. Due to negative charge also I've drawn it towards. Right? Towards the negative charge. And this red one is away from the positive charge. Right? This I'll write away, while the blue one is towards. Right? And let's find the value of E2. E2 will be K due to the blue charge. Magnitude is K Q by R square. In this case, B square. Okay. So what is it? And both are in the same direction, guys. So they will get added up or subtracted. Get added up. So net electric field will be E1 plus E2. So just add them, you'll get the answer. Everything is given. K is given, Q is given. Q is 25 microcoulomb, right? Just add it and you'll get the answer. Coming out to be KQ taken KQ. Right. That's the net electric field. Now you have, let's say, Q and Q. I need to find a electric field at the center because of Q and Q. What will be electric field at the center? Center means midpoint. So you can say that because of this charge, electric field plus will be away. How much is the value? KQ by R square. Because this red charge, it will be also away. How much? KQ by R square. And they both will get cancelled. The net electric field will be 0. This we have already seen before, I think, right? Here the field net electric field is 0. This the other case we have already seen. Now let us say there's a uniform, let a uniform charge. Let a uniform charge be distributed on the entire ring. What would be the electric field at the center of the ring? So that means I'm giving plus charge everywhere. What is the electric field at the center? You have to find out. Electric field at the center. So electric field will be how much? Let's see. See this due to this portion, electric field will get. So this portion will send the electric field in this direction. This portion will send the electric field in this direction. Right? And this portion will send the electric field in this direction. So both the electric fields will get cancelled. Similarly, this part will send the electric field in this direction. This part will send the electric field in this direction. Both will get cancelled. So net electric field will come out to be how much here? It will be 0. Okay. In the given figure, if Q1, Q2 are positive, where could a negative charge be placed so as to have vertically upward net force on it? So Q1, Q2 are positive. Where could a negative charge be placed so as to have vertically net upward force? See, two things. One is negative charge. Where could a negative charge be placed so that we have vertically upward force? You want force upward direction, but charge is negative and force is upward. That means the electric field must be downwards, right? On a negative charge only, when force is upward, the electric field will be downward. So I want to find a situation where electric field will be downward. Agreed? Because charge is negative. I want the force to be upward. On a negative charge, when is force upward? When the electric field is downward. Makes sense, right? Electric field must be downwards. Now let us find out at which point electric field comes out to be downwards, right? So let's check this charge. Due to this charge, at this point, electric field will be in this direction, right? And both are positive charge, right? Both are positive. And due to Q2, electric field will be in this direction, right? Now think where will be the net electric field, in which direction? Upward or downward? So there some will come out to be in which direction? Upward or downward? So by parallelogram, it will come out to be upward. But we want a situation where electric field is downward. Here the electric field is coming upward. So B is the wrong point. Now let us check D point. It will be in this direction. But the green one in this direction. So the sum will come out to be in which direction? Their sum will come out to be somewhere in this direction. So electric field will be in this direction. And that is what we wanted, right? We wanted electric field to be in the downward direction so that the force could be in the upward direction. So which option is correct? Okay. Write it down. in the given figure is the vertical distance from E to B. Okay, how much time? Time's almost about to be over. Fine, we'll do this question next time because we have to find the magnitude of light field. That's a lot of calculations will be there.